Tsunami characteristics. The physical parameters of duration, length, propagation speed, and heights are the keys description of tsunami. In this regard, tsunamis have duration is ranged between 5 to 100 minutes. They have long length which is ranged between 100 m to 1000 km. Further, tsunami propagation speed is between 1 to 200 meters per second, and their heights can be up to tens of meters. Therefore, Saabo et al. Stated that tsunami waves of the seismic origin are usually very long, 50 to 1000 kilometers. In this context, the source of the giant 2004 tsunami in the Indian Ocean, magnitude of MW 9.0 to 9.3, has approximated dimensions, I, length, 670 kilometers, 3, width 150 kilometers, and 4, height 12 meters. This means that a tsunami can propagate long distances before it strikes a shoreline hundreds or thousands of kilometers from the earthquake source. To accurately model tsunami propagation over such large distances, the Earth's curvature should be taken into account. Other factors, such as Coriolis forces and dispersion, may also be important. Tsunami generation. It is interesting to understand the mechanisms of tsunami generation. Generation mechanisms of tsunamis are geological events like land and rock slides in fjords and lakes, submarine gravity mass flows and earthquakes. The storage slide is one of the largest submarine slides in the world. While the mechanism for generating the initial water waves by purely tectonic motions is reasonably well comprehended. Conversely, the modeling of tsunamis generated by submarine landslides is not yet explicated. Coseismic deformation of the seafloor usually occurs rapidly relative to the propagation speeds of long water waves, allowing for simple specification of initial conditions by transferring the resultant permanent seafloor deformation to the free surface. However, subaerial and submarine landslides move less rapidly, and the time history of seafloor deformation is important, necessitating the addition of source terms in the equations of motions. Compared with the understanding of earthquake-induced initial tsunami waves, the understanding of landslide-generated waves is marginal. Briefly, in terms of the semi-analytical empirical studies transferred the energy released by a moving block sliding from its initial position to its final position to solitary waves and calculated the height of the wave. Tsunami generation due to motion of fault block.